Leading zeros are not significant. So you only got 3 significant digits. You need 3 significant digits in the final answer, so that's the answer you get. Okay? All right. Then there's this number called the auto-ionization constant for water. And the symbol for this is K for the constant, and to identify which constant it is, small letter W or the letter W in a subscript position. Now this is a capital K. All right, it's not just any constant, it's a pretty special constant, so we use capital K for this one. Okay? Constant. It turns out that in any solution in which water is the solvent, that the concentration of hydrogen ions multiplied by the concentration of hydroxide ions in any solution in which water is the solvent, when you multiply the hydrogen ions concentration, molar concentration, times the molar concentration of hydroxide ions, you always get the same number. So it's a constant. And since the concentration of hydrogen ions means essentially the same thing as the concentration of the hydronium ions, just using 2 different acid-base theories, then H3O plus, which is hydronium, times hydroxide, is also going to equal to this Kw. All the time, every time, as long as you're at roughly room temperature water. Okay? So this is only for water. At about 20 degrees centigrade or Celsius. Okay? But that's all we're going to be working with in here is water at 20 degrees Celsius. Okay? That's roughly room temperature. Slightly cooler than average room temperature. Okay? Room temperature in the Celsius scale is about 22 degrees C. Okay? All right. And Kw has an actual numeric value, otherwise it wouldn't be a constant. Okay? Kw is equal to this number, 1.00 times 10 to the negative 14, molar squared. You might want to note on your test references that it's right there. And so are the formulas for pH and pOH. Okay? Got that? All right. Now, on your test references, it doesn't show the units of measurement, but the units of measurement are molar squared. Okay? So if we know the hydrogen ion concentration, and we always have the constant here, we can calculate this, just like we did in the gas laws. If we have 2 things in this kind of equation, we can get the third. That makes sense? No? Okay. All right. So let's go back here and look at one of these equations, calculations we just did a minute ago. Let's start with this first one right here. Okay. The concentration of hydronium in this one is 0.0125 molar. Okay. Remember the word aqueous means it's dissolved in water. Okay, so water is the solvent. All right. So from the concentration of the hydronium ion, we're going to find the concentration of the hydroxide ion. Okay. So I've given you the concentration of the hydronium ion. That's this part right here. I've given you Kw. You got to just find this stuff right here. That's the symbol for the molar concentration of hydroxide ion. Okay? So let's write it this way. Kw equals hydronium ion concentration times hydroxide ion concentration, and plug in what we know. We know the Kw. We always know the Kw. That's 1.00 times 10 to the negative 14 molar squared. The hydronium ion concentration we know is 0.0125 molar. We just don't know this. That's what we're trying to find. Times the hydroxide ion concentration. How do we find the hydroxide ion concentration? What mathematical manipulation did we use? I divide both sides by, right, to isolate the unknown. That's what we called it in Unit 7. We want to isolate the unknown. OH, this OH negative in brackets is the unknown. We've got to, in this case, since this is a multiplication problem, we've got to divide in order to get rid of this term right here on the right side to isolate this by itself. So 0.0125 molar. And what we do to this side, we've got to do to the other side. 0.0125 molar. So this entire term here is going to cancel out. Remember, molar squared. What does squared mean? It means you're multiplying this term by itself, right? So this is molar times molar, right? So I can cancel this 2 out with this right here. Does that make sense? Yeah. If I were to write this out as molar times molar, that's the same thing as molar squared, and put it over molar, I can cancel one of those out, right? Does that make sense? Okay. And so now we just got to plug it in the calculator. Now this is where the really inexpensive calculators will cause you major headaches. I'm sorry, that's the way it is. All right, you got to learn to use it. Okay. All right. But let me show you. Well, first of all, let me show you how to do it on a better quality calculator. On a better quality calculator, you just put it in the way it looks. Okay. So I'm going to put a set of parentheses on the top here. 1.00 e to the negative 14. Okay, that's this number here, times 10 to the negative 14. It's the same thing as e to the negative 14. And then I'm going to divide by, and put this over parentheses, 0.0125. All right. And some calculators you have to put in the extra exponent. This one puts it in for you. And I put enter, and this is the number that I'm going to get. Now for some of you, it's going to be a lot more complex, and I'm sorry. That's the nature of it, okay? But what I've got on my calculator, so we know our hydroxide ion concentration is 8 times 10 to the negative 13 molar is equal to the hydroxide ion concentration, okay? But how many significant digits do I actually need here? 3 significant digits. So I need to write the answer as 8.00 times 10 to the negative 13 molar. Okay? If you have a less expensive calculator and you've got exponents, you subtract those. Okay? So you'd first take the numbers that aren't exponential on the front and divide those, subtract the exponents on the back side, and then put it all back together. Does that make sense? All right, let me show you how I'm going to do it here like this. I'm going to say 1.00 divided by 0.0125. And what I'm going to get is this 80. Okay? Using this system, I'm going to get 80. All right. Now I'm going to take times 10 to the negative 14, because I haven't done anything with this. Okay? All right. Now to find out, this is not in scientific notation. Okay? To put it in scientific notation, I need to move the exponent one place to the left. And this changed to a negative 13. Gives me the same answer. However, if you don't know that, here's what you do. You take that 80 right here, 80 exponent, 14 negative. That's what we need. 80 exponent, and then you have to hit the negative after you put in the 14. Okay, let me show you again. Every calculator is a little bit different, and I have to go back through them sometimes, remember, 80, exponent, 14, and then hit the change of sign to get a negative 14. When you do that, then you're going to get the same number, 8 times 10 to the negative 13. Guys, all right? So you will get the same answer. All right, this number I can write it as, let's do this, 0.00 times 10 to the negative 14 molar squared. I'm going to write this number here in exponential and scientific notation. 1.25 times 10, move the decimal place 2 places, times 10 to the negative 2 molar. Okay? So if I'm going to use the calculator to get these answers, I'm going to take 1 and divide it by 1.25. Whoop, turn it on, I guess. 1.00 divided by 1.25, and I get that 0.8. So 0.8 times 10. Now I'm just going to subtract these two numbers. This number I'm going to subtract from that number. Okay? And when you subtract negative 2 from negative 14, you get...
What?
When you subtract negative 2 from negative 14, what do you get? Negative 14 minus 2. So you subtract those two. You get a negative 12. Okay? So this is times 10 to the negative 12. So now let's put that in the calculator.
Wait, didn't you say negative 14 minus 2?
No, it's a negative 2. Because there's a negative 2 right here. Negative 14 minus a negative 2. Well, I'm saying now, negative 14 minus a negative 2. Okay? We're going to take and put an exponent on there of 12, change the sign, hit equals, and we get the same answer again. Okay? 8.00 times 10 to the negative 13 molar. All right. So if you have a less expensive calculator, you've got more work to do to get an answer. Okay, here's a new problem for you. If the hydroxide ion concentration is 9.35 times 10 to the negative 11 molar, what is the hydrogen ion concentration? Please solve this problem now.